Build Show today, we are talking Monopoly framing. We're visiting Whit, my engineer, who's building his personal family home on this incredible ranch property outside of Austin, Texas. And I gotta tell you, this isn't just normal Monopoly framing. There's some details here that are gonna absolutely blow your mind. Today's Build Show is sponsored by Huber Engineered Woods. Let's get going. Everybody loves a good job site mock-up. It really shows the details. Whit, the house is looking amazing, man.
Thank you, Matt.
So Whit, family home, you and the kids, this is your personal property. This is a big deal for you. I suspect you're gonna be in this house a few years.
I see us living here a long time.
I love it.
The kids are grown and gone, and maybe we have grandkids here one day.
So with that being said, we're building a house that's gonna last. I love seeing a job site mock-up. Walk me through the details, because this is kind of a modified Monopoly, right?
Yeah, well, this was largely inspired by things that we've learned together over the years, things I've seen you all developed, and this is this Monopoly concept that is continuously air sealed, taped from the roof all the way down to the wall, all the way down to the foundation.
Just makes a lot of sense, doesn't it? The face of that zip is our air barrier, but also it's a great water barrier. So by having that continuous foundation all the way to the ridge, nothing's getting through there.
Yeah, exactly. Air sealing,
bugs, humidity, the whole shebang, everything's blocked out from the get-go.
That's our goal.
It's a big deal. Compared to the old days when we would house wrap houses, we'd have all these rafters poking through, there'd be miles of cracks that needed sealed, we'd be relying on spray foam for air sealing, which kind of did an okay but not great job. This is a fabulous wall.
Yep.
Now talk to me about this. You got like a 6-inch or so overhang, and then a short fascia, and then it jogs back up. What's happening there?
We don't have a traditional long overhang on this house. We're actually gonna have a CMU veneer that comes up to the underside of the house. So we will have a masonry veneer with an air cavity behind it.
Okay, so I've seen the plans. What's the style of architecture you're talking about here?
Oh, it's kind of a mass wall. It doesn't have an exact style. Maybe the closest style might be like a Cape Dutch description, where we're gonna feature some parapets on the house.
Yep.
But really, it's kind of inspired by some of the mass wall things we've seen over the years, whether it's an old church or an old Pueblo type building.
It feels very Texas to me.
Yeah, I think
like
so.
it.
I mean, it'll have deep window seats. It'll be a thick wall assembly.
So there'll be CMU in the outside in various thicknesses. That'll get stuccoed over the top, but you're using that CMU to form the parapet walls, which go up beyond the framing, right? So all the framing's inboard of that. Everything that's CMU is outboard of that.
That's correct. That's really what inspired all of this. We didn't start off with a CMU home. We always knew we wanted a wood framed home, but we have these parapet elements that we were going to try to do out of wood with stucco over the top of them. And as we investigated different detailing options, everybody kept coming back to the idea that we needed a metal cap over the parapet. They said nobody would touch it if we didn't have a metal flashing cap over our parapet. And that would have just killed the whole look of it. You know, it began to look like a retail center with,
or a
with a metal
restaurant.
cap. Exactly. So then we started thinking, well, what if we just bring this parapet out and have a CMU facade that we bring up outside of the wood framing?
Right, because CMU doesn't get hurt by water if you got some water intrusion in there, right?
Yeah.
It's nothing to rot.
Yep.
So we stucco that, and then we don't worry about it.
That's our thought.
And then also we're gonna have an air gap. So what's happening with this zip rain screen? Actually, let's walk over here. I'm also want to ask you about that base wall flashing detail you got here.
Well, again, this was inspired by videos that we had seen of yours in the past, where we had, I think you all called it like a Zip 2.0, where I saw a video where you all liquid flashed the lower portion of the wall.
Yeah, my buddy Doug Cameron came up with that idea, and I loved it.
Well, we were inspired by it because we know we're gonna have this CMU veneer. And as we look at some of the 2-story volumes, in my mind, I just have this concern of mortar and things falling down behind the CMU as they lay it up. And not all of our lugs are this deep. Some are more shallow on the front of the house. So I actually contacted our Huber rep to get their opinion on using this liquid flash on this lower portion of the wall to protect the wall. And they recommended this product. And I'm glad they did. I like it even so much better than just the liquid flash.
Yeah, so if you're not familiar, this is like almost like a Brillo pad behind here that gives about just shy of a 1/2 inch, right, of air gap in front of the zip. And then this is a true kind of WRB on the front too, right? That's vapor open, so it could dry through there. But what it means is now any mortar droppings aren't gonna clog up and actually touch the face of the zip, right?
Yeah. Now, I don't expect a lot of moisture to hit the lower portion of our wall. Right. However, during a remodel project, you know better than me, when you open a wall up, any water damage we do see tends to be on the bottom 2 feet or so of the wall.
Yeah.
So we're hoping this provides an extra layer of protection, you know, against sprinklers, wind-blown rain, any type of moisture that might come in contact with this lower portion of the wall.
And then you taped it here, so if we did have something that got in, it would run to the face of this zip before it ran out the bottom. Also notice you got that brick lug really smart. That's below the framing, which is actually here by at least, I don't know, 18 inches maybe. So that's really smart.
Yep.
And also I want you to notice, he's got at least a foot or so of true foundation showing. It's a mistake to run your CMU, your brick, your stucco all the way to grade, especially in Texas or anywhere where there's termites. You want to be able to see that termite path up and go, oh, wait a minute, we got some intrusion here. Let's take care of it. If you put this masonry below grade, they can get in and you never know it. Did you do that on purpose or was that a happy accident?
That was just one of the reasons. And other reasons are we come in and weed eat around our house, and it just kills me when we come in and work in our yard and weed eat up against stucco or masonry and just tear it up over the years. You know, you think it's going to be durable and it never is. So this is the finished foundation as far as I'm concerned.
I love it. Really good. So when I look at your roof line, I'm noticing we go up and we're fully taped as we hit that flat soffit. You've got zip on the soffit, and then you've got a little piece of zip on the fascia. And then talk to me about the roof detail. Are you doing an over roof? What's happening up there?
I would love to do an over roof, but I must admit, we do have a budget with our project. So, and
your
in my
family
mind,
house.
It's a budget driven project, just like they all are. And I would have loved to have an insulation buildup outboard of this. I didn't see us as having the budget for it. So instead, we carried the zip all the way up over the roof.
Okay.
I once again talked to our Huber rep. We taped all those joints before putting our peel and stick roof underlayment on top.
And you got a full peel and stick on the whole roof.
Yes. Yeah, I thought it was important to distinguish that you do tape the joints before the peel and stick. Even though to me the peel and stick looks like one big layer of zip tape, it's not the same thing. So you do tape the joints first, then peel and stick.
And that's the Huber peel and stick product too, right?
Yes,
Which I think is a high temperature rated version.
It is. They have two, and because we're here in Texas, we have the high temperature one.
So now if anything happens, your roof comes off for whatever reason, some terrible winds, a tornado comes through, we're fully sealed at the roof deck. So that now we might have a couple of pinholes where some nails pulled out, but other than that, you're not going to lose your house because of a flood.
Yes, sir. Exactly.
Super smart.
So in the spirit, though, of the continuous insulation, even though we're not insulating on top of the roof, we are going to insulate continuously on the underside.
Yeah.
This is a zip R panel, so we have our continuous insulation on the exterior, and then we're going to continue that insulation up on the interior as well.
Okay. Very good.
So yeah, it will be continuous and uninterrupted by the framing.
What will your roof end up being? What's the final roof on this house?
It's going to be a Galvalume standing seam roof.
Oh, fabulous. Will you vent between the Galvalume and the peel and stick there somehow?
We're not going to vent it. It's going to be directly applied to it. Once again,
it's going to get hot up there.
It will get hot. We're going to insulate it pretty heavily. We haven't settled on the solution yet, but we have a few good options that we're looking at. It's going to be more than code minimum for our roof insulation. So it's something I'm going to talk to you more about because I have some ideas. We'll see how they play out.
We'll come in and take a look at that in a second. Now, Whit, when you came out and inspected a house I did recently with Zip R, this is the R6 model. When I first started nailing it off, I actually made a mistake and you caught me and mentioned, oh, Matt, you got to double check your spacing on these nails. This Zip R has 1 inch, so it's R6 of foam that's in between the framing and the exterior zip. Talk to me about nail patterns.
Two things you need to know about is nail length and nail pattern. I actually think they describe it by shank diameter, which is 0.131. That corresponds to a 10D nail for all the framers who are out there. That's a 3-inch long nail. So we're going to use a 3-inch long 0.131 shank diameter, nailed it 4 inches on center around the edges and 12 inches on center in the field.
Okay.
That's different than your conventional sheathing, which would be 6 inches on center around the perimeter.
Gotcha. The nice thing about that nail size, correct me if I'm wrong, that fits kind of a standard nail gun. We don't have to get to some oddball or some weird nail gun. You can get those nails anywhere, right?
Yeah, that's exactly right. It's the same nails they use on their framing. So these guys sheath it with their framing guns instead of a sighting gun. That's the only difference.
And then I noticed you actually did Zip 2.0 all the way up rather than just focusing on those bottom 2 feet. So you liquid flashed everything as you came around that.
Yeah, you know, that's me being a paranoid engineer. So, you know, we kind of, everybody has their things that are important to them. You pick your battles. To our point about exterior insulation at the roof, I would have loved that. We kind of look at pricing for each different phase. And this was one that for a little additional cost, it was worth it to me to go ahead and pookie each nail hole, even though it's not required.
A little extra forgiveness, but Huber doesn't require that.
Yeah.
Now, did you talk to the Huber engineers at all as you were designing some of these systems?
Oh, frequently. You know, well, I say frequently. On occasion, they're to their credit, they were very responsive to us. There were days we'd show up on the job site to discuss what we were going to do that day. And then I would call them to confirm that I was going in the right direction with this. For example, they were the ones that recommended the rain screen in lieu of the liquid flash up the wall. They were the ones I called them on day of as we were doing roof underlayment. You know, we were prepared to tape all the joints, but I didn't want to have the guys do double duty if not necessary. But they were able to answer that question for me.
That's awesome.
On the day we were about to start putting underlayment down.
I love it.
Yeah.
I want to rewind time for a second because I'm curious about you. My story on Huber is when I first started seeing this product on the market 20 or so years ago, I was sold on house wrap and doing house wrap details correctly. And when I first saw it, I thought, you know, that's the dumbest thing I've ever seen. Sheathing that has tape on it. And the story I would always tell people is like, when was the last time you saw duct tape that survived outdoors for more than 6 months? It would peel off. And so I was a total detractor. I thought it was stupid. And then I started seeing people using it, yes, but even more importantly, I saw the work that the University of Texas Durability Lab had done on Zip and some other products as well, testing it against UV rays and testing various tapes for how well they would last in our really hot environment. And this really smart guy, David Nicastro, was running that at the time. I think he might actually be retired now. David's amazing. He's the guy that coined the phrase, if it can't dry, it's gonna die. Anyways, long story short, I saw a bunch of testing, including nail penetration testing, where they tested the zip, they tested the tape, and over a period of a couple years, I realized, gosh, they actually engineered the heck out of this product. I was really starting to realize this is actually a pretty incredible product. Do you remember how your initial thoughts about it and kind of, do you look back on that and think, gosh, I just didn't know what I didn't know?
Engineers are naturally not early adopters. You know, I don't think that's going to come as a surprise to anyone. We like tried and true systems that have been tested by time. For whatever reason, I didn't really have any objection to this. I was really interested in it the first time I saw it. So I have some of the same reservations about the tape. When I first saw it, my initial thought was I would liquid flash all of these because I can wrap my head around caulk or liquid flashing adhesives. I wasn't sure about the tape, but the same, everybody knows you must roll the tape. They do a great job of making that very clear. It's got about every 6 inches on there. It says roll the tape. You put it on, you roll it, and you come back a day later, and that stuff is just like cemented on there. You know, so no, I always thought it was a really good concept. I was always eager to try it. You know, now I see it used on our jobs very regularly, but I've never used it on a personal project. So, and the guys have been so nice to put up with me. I look over their shoulder, you know, I come out every day and see what they're doing. Again, I'm a wannabe builder. You know, so I sit out here and talk to them about how it's going and what's working. And
that's awesome.
You know, always a little something you do different, but for the most part, it's been very user-friendly and we've enjoyed working with it.
I love it. The other thing I want to mention at this stage that makes a lot of sense, you know, where you've got a pipe sticking out, or you got something sticking out, like this pipe above this window, you know, it's super easy to come back later with either stretch tape or liquid flash and make a connection between that pipe and the green face of the zip. It's like really easy to see that detail that's not quite right that you need to come back and finish, right? Because the plumbers are here today and they may have poked that pipe an hour ago. But it's one of the things I really like about the zip system. We can see what needs done, and frankly, anybody, you could even get up on a ladder and do that. You don't have to have special skills, and we can walk around and go, hey, there's one thing we need to button up there or there. And then once we do that with this Monopoly framing, we basically have a really tight air connection between the framing and the foundation with the liquid flash. We're taped and sealed all the way to the ridge and all the way back down. When you do a blower door test on this house, I bet you're gonna be like 0.3, 0.4 ACH 50, super, super tight.
Yeah, no, that's one of the things I like about it is the homeowner, you know, I come out at the end of the day and poke around and I can see, you know, it's got the Z stamped on the tape, so I know that it was rolled. I can look underneath and see that it was air sealed just right, and it just gives me a lot of peace of mind. To the penetrations, another thing I learned from you all is one pipe for one hole.
That's right.
So with each trade, we've had that conversation here.
That's awesome.
You know, so you do that, you come back and seal around it, and you get to inspect it one last time before the cladding goes up, and you can really feel good about it.
Yeah, I love it. I did the same thing in my house. One pipe for one hole. That's Jake Bruton's saying. Just makes a lot of sense. Let's switch gears and go inside. Let's show you a couple of the framing details. There's a couple things that you've not seen before inside. Hey Whit, before we go in, I just noticed now, it looks like your Pella windows and doors are maybe bucked out by, I don't know, 3/4 inch or so? An inch?
Yep. No, this is a detail we actually worked through with Pella. We're going to have a CMU veneer on this house, And in order to bring the windows out flush with this, in a way that the CMU returns nicely up against the window, we actually had to bring the window out 3/4 of an inch. So
Gotcha.
again, we worked through our details with our trade partners prior to beginning this. I mentioned this, I showed our wall assembly to Pella, and they provided us with this detail showing us how to flash it, how far to bring it out, and that includes the head flashing and everything. So
Smart.
This was the result of that effort.
And so with your CMU, which by the way is getting stucco later, it's not a CMU facade, it's a stucco facade, but it's actually stucco on real CMU. What's the air gap behind there? And like normally you think of just the width of mason's knuckles, but you're actually going a little wider than that.
It's a little wider. We did a CMU block is going to be a 5 5/8, and we have a 7-inch lug on the house. So this is an 1 3/8 air gap. We just did it that for a nice round number, good airspace behind it.
That makes sense. Okay, so that's why these are bucked out. Okay, I gotcha. All right, as we walk in, I'm immediately struck by that back of that zip bar, that continuous insulation. And it looks like these taller walls are 2x6. Is the whole house 2x6 construction?
No, we only used 2x6 where we needed to because of the wall height. I'm a structural engineer by trade, as you know, and I have full confidence in a 2x4 wall. You know, there's always some conversation, do I need, should I use a minimum 2x6 for strength?
Yep.
I've always been perfectly happy with a 2x4 wall, in a 9-foot plate.
Yeah,
so,
and fully sheathed.
Well, and fully sheathed, of course. In my world, that's assumed.
You must fully sheathe.
Yes, that's
and not with cardboard.
Take that for granted that we're going to have an OSB or plywood sheathing.
Yeah.
But yeah, with that said, I mean, this is something we talk about a lot, internally within the office as we discuss building assemblies. If given the choice between a 2x6 wall with no exterior sheathing or a 2x4 wall with an exterior, I said sheathing, I meant insulation.
Right.
I'm taking the 2x4 wall with continuous insulation all day long.
If you just look at the nominal numbers, a 2x6 wall with standard zip and we just insulate the cavities, we say we're putting an R19 bat in there, but we're not getting a true R19, right? Look at this wall right here. If we put an R19 bat here and we didn't have that 1-inch exterior insulation on this wall with this additional framing, we got a header, we got all this additional wood here, that's not an R19 wall if it was standard sheathing, right? The effective R value is probably like R13 or R14 on that wall. Studs do have insulation value. It's roughly R1 per inch. So this is maybe an R6 stud, but this R6 stud now has R6 on the outside of it too. So right here, the actual R value of this location is actually R12, right? And then what's happening with your cavity insulation on this job?
I think we're going to go with a blown-in blanket type system.
Okay,
so
cool.
bibs. Yeah.
So you'll be like R21 with the bibs, plus the R6 in the background. If we were to do the math, your effective R value is probably R22 on this wall.
Yeah. So
something like that.
Still a really good assembly. I will tell you, no matter how many details we draw, no matter how many conversations we have, it always end up getting filled in with framing.
Right.
You can have the best of intentions, even with the advanced frame, which I'm a fan of. I think it's a great system. Inevitably, each trade comes in and adds their blocking and their additional studs, and before you know it,
you got some additional wood in there
that you didn't plan on. And again, continuous insulation on the exterior takes care of that.
Yeah, for sure. Can I point out something that most people wouldn't necessarily notice? That does not look like a standard washer to me. What's going on there, Whit? Talk to me about that.
This is a slight upgrade. Once again, structural engineer, so these are the little things we think about on a daily basis. That's just an oversized plate washer.
Okay.
They're 99 cents a piece at Home Depot. We come in here and add those. It provides additional resistance to uplift. It never fails when we drill these holes for these bottom plates. The hole is oversized, so if we were to pull that off, I think you would see that the hole in that plate's close to the size of a standard washer. So for a nominal cost and for me to sleep good at night, we just come in and we put those oversized washers on there.
Makes a ton of sense.
It adds a ton of strength.
Yeah, I love it. Now, as I look at these trusses, Whit, I'm seeing a detail that I've never seen before that I'm really curious about. And let's see if we can, this may be the best place to look at it right here where the light's really good. Look at that top cord. It's got actually like railroad tracks there. It's got 2 top cords or like a parallel cord just below the top cord with maybe a 4 or 6 inch gap. What's going on there?
Well, yeah, again, this is a personal project and I can't help but experiment with some things, or I have these ideas that seem like great ideas at time that maybe don't pan out. This is one of them, and I'm still investigating it a little bit. Again, because we're not insulating outside of our roof here, I'm trying to keep it all on the inside.
Yep.
my goal was to provide extra insulation up in the plane of the roof.
Yep.
And I wanted it uninterrupted. I want continuous insulation, very similar to what we would get outboard, but always the framing interrupts our insulation. So my thinking here was I might come in with a bat type product. That's a 3.5-inch gap between those cords. So I was thinking, and the top cord is 3.5 also. So I wanted to get 3.5-inch bat between the trusses, 3.5-inch bat perpendicular.
90 degrees to it.
And then
running through and held in actually by that.
Exactly. Those are intended to support that second bat.
Smart.
And then have a third one. So if they were R15 bats, I would get an R45 that's almost continuous, except for the little interruption by the occasional web member of the truss.
That's really smart.
So it might work. It might be a complete fail, because that sounds like a lot of extra labor to come in and tuck all those bats up in there. So the fallback plan is to do what everyone else does with truss roofs and spray foam it.
Now, let's address the spray foam thing, right? In Texas, there's a lot of contractors that use open cell spray foam, and so prices are actually pretty reasonable on open cell because it gets sprayed a lot. Now, I've moved to a lot of closed cell. I like closed cell. That's still pretty dang expensive because it's not sprayed very much. But one thing I found when I talk to people about open cell is there's a lot of folks in Texas, sometimes insulators, who say you can get away with, let's say, 5 or 6 inches to meet code of open cell spray foam in your roof line. What do you think about that?
This has been something I've had a hard time with for years now. You know, I spend a lot of time up in attics for various reasons, looking at structural items, and by far the standard is about 5.5 to 6 inches of spray foam.
In Texas.
In Texas. And again, we see it all the time. And I ask the question, why don't I see more insulation up here? This doesn't meet code minimum. And again, friends will be building a house and they'll ask for an opinion. I'll review their proposals, and they're going to put 5.5 inches of spray foam in their attic.
Yep.
Each time I ask the question, and I'm informed that it is a effective assembly. It's effectively R38, which is what we're supposed to have in our attic. You ask the question so many times and you begin to think you're the crazy one when the whole industry is telling you that, no, we're doing it right and you're misinterpreting the code.
Yeah.
I'm still firmly of the opinion that you need a whole lot more than 5.5 inches of insulation in between a 2x8 rafter.
In open cell.
Yeah, open cell, yes.
Sure.
Because
I mean, if I'm doing the math right, open cell's around 3.5 per inch, right? Somewhere in there, maybe 4. So times 6, that'd be R21. That does not meet code in Texas in climate zones 2 or 3 for a roof line.
The best I can figure is when I look at the code, there is a provision for continuous insulation above the roof. And I think it used to be R20, it might now be R25. The best I can assume is that the industry is reading that and interpreting it for spray foam at the roof. I think they're interpreting that as continuous insulation in the roof.
Not though.
It's interrupted by a rafter every 24 inches.
Exactly.
So with that said, we do have a spray foam estimate for this project. It's very competitive. It's for 5.5 inches only. So I'm going to be having them revise that to, I'm thinking 9 to 10 inches.
Yeah, 10 inches is perfect.
And then we're going to compare this to some of my other bat product ideas and see where we land.
I like it. One interesting thing about that double rafter, at the very bottom of that is probably close to 10 inches, right? Because you said 3.5, 3.5, 3.5.
Yeah, that's right. So about 10.5 inches.
So 10.5 inches. So if you were to do open cell spray foam, you would have a good gauge right away without having to get up on a ladder and use a poker to see how thick it is too.
Yeah, exactly.
So that's actually another benefit of that. That's not a free detail, don't get me wrong. You spend some bucks on that.
Yeah.
But there is some benefits, and I like the idea that you could use. Now, if you did use spray foam though, would you do anything different with penetrations, let's say?
Yeah, for sure, because there are a lot of benefits to spray foam, but again, me being an engineer tends to find things to worry about that I probably shouldn't worry about. One of them is roof penetrations. So we've, here with all the trades we've already discussed, having wall penetrations to the extent we can. Any plumbing vents that we have, we've ganged them up so we only have one penetration on each side of the house instead of multiples in one roof. But with that said, with spray foam, I still worry about getting leaks there. I've lived in previous homes where we get small leaks around penetration. So what I think I would do, even if we do foam the roof, I'll probably still come in with a bat product in those locations, just so if we ever needed to open up and inspect those areas, we'd be able to do that.
So you could basically just take 12 inches around each one of those vents, block it off with a 2x10, let's say, have the spray foam guy spray up to that, and then just lace bats up in there with a tiger claw or even just some strapping to hold it in place. So 10 years from now, if you want to get up there, you can just take that down and double check. Oh yeah, everything's perfect. Good to go. No water here. Put it back up. You're good to go. Kind of an inspection port idea.
Yep.
I love that. Whit, fabulous house, man. I absolutely love where you're going with this. This is definitely a house that meets Joe Stiebrick's 500-year wall concept, which is where Monopoly framing came from. It's the perfect wall that Joe Stiebrick put a paper on, I don't know, 20 years ago now. I'm super impressed, man. Your family's gonna love this house.
I really appreciate it.
Super cool. Guys, we're gonna come back with Whit in a future episode, talk about his Pella and his details on his windows, because he got some interesting stuff going on with the house. So stay tuned for that. We might talk him into coming back again for the CMU and the stucco too, because there's some other cool stuff happening here. But I really appreciate you giving us the full tour of your family house. Beautiful work, man.
It's been a pleasure.
Guys, if you're not currently a subscriber, hit that subscribe button below. We've got new content here every Tuesday and Friday. And oh, by the way, over on thebuildshow.com, we're publishing like 15 videos a week. And we've got our second annual Build Show live conference in Dallas, October 16th through the 18th. You got to come. We're going to be talking about Monopoly framing. We got all kinds of good building science education. It's going to be worth every penny of yours to fly into Dallas and come to that conference in October. So buildshowlive.com for tickets. Thanks to Huber for sponsoring. Hit that subscribe button below. We've got new content here every Tuesday and every Friday. Follow us on Facebook or Instagram. Otherwise, we'll see you next time on The Build Show.